In this video, we're going to look at the total cost of a loan, and we're going to look at 3 different options. And each option is a little bit different of a type of loan, and then the rate changes. So this is going to be a long example, but it's an interesting example because we really get to see the difference that all of these variables make when it comes to factoring total cost of a student loan. So Parker needs to take out a $50,000 student loan for 2 years and 3 months before graduating. Which loan option will result in the lowest overall cost? Assume all payments are deferred for 6 months after graduation. So we're going to first look at option A, which is a subsidized loan. And you might remember that a subsidized loan is a loan where the government pays the interest. So I just wrote down here, no accrued interest. So we don't have to figure that part out. So this is this will be the easiest one, option A, less work in terms of calculating. So all we have to do is jump into the monthly payment, because if we want to find the overall cost, the first step is finding the monthly payment. And then we can use the monthly payment to find that overall cost. So for the monthly payment, we're going to use the monthly payment formula, which is right here. And our principal is just going to be the loan amount. So $50,000, because remember, the government pays that interest while Parker's in school. So then our rate is going to be 6.7%. So I just take the decimal and move it 2 spots to the left, or divide by 100. So 0.067. And then the term they tell us is 10 years. So I'm going to take all those values and I'm just going to plug them in the monthly payment formula. And then to the -12 times, in this case, it's 10 power. So if you have a TI 3430, you can use that N over D button. So 50,000 times N over D 0.067 down arrow 12. And then remember, if you have a different type of calculator, you're just going to use the division sign instead of that N over D button, and I can show you that in a second. So I'm just typing this in exactly how it looks on my paper. And then always make sure you use the right arrow to get out of the denominator or the fraction. That can, throw it off if you stay down there when you press the exponent button. So now that I'm out of the fraction, I can press the exponent button. And then the -12, not the subtraction sign, but -12 times 10 power. And so we end up getting a monthly payment of $572. And we always want to round to the nearest cent, so that'd be 84 cents. Per month. So that's my monthly payment per month. Okay, and then in case you don't have this type of calculator, I'll just show you real quick. So you would just type in 50,000 times 0.067 divided by 12. So you don't need that fraction button. And then you write down the numerator. So you just write down 279.1666666. I always keep all the digits. It keeps the answer precise. And then I'm going to do the denominator. So I'm just going to type in 1 minus parentheses 1 plus 0.067 divided by 12 and parenthesis, and then raised to the -12 times 10 power, or you can just multiply it ahead of time and just get -120 and do it that way. And then you're going to write down your denominator. And then you can divide these to get your answer, or you can use, there's this answer button, which is really helpful. So 279.1666667 divided by, and instead of typing this all out in the denominator, you can just hit second and then the answer key. And it may be in a different location if you have a different calculator than me, but most calculators, graphing and scientific, have that button. So check it out if you have a different calculator. I bet you might be able to find one. And then notice you get the same exact answer as above. So this formula you should be able to do this formula no matter what type of calculator you have. And so then for the total cost, what we're going to do is we're going to take that monthly payment, and I'm actually going to come down here so I have more room. So for total costs, we're going to take the monthly payment of $572.84 and multiply it by 12, because there's 12 months in a year, and then times 10, and this is number of years. So, and that will give you the total grand total that the student pays in the end. So times 12 times 10. And we end up getting $68,740.80. So just think about that for a minute. So Parker takes out a $50,000 student loan and ends up paying $68,740.80 in interest. And if you're wondering how much interest, all you have to do is subtract. So if you take that 68,000 number and subtract 50, you get a little over 18,000. That's $18,000 that the student is paying just in interest. Okay, so let's look at option B. So for option B, we've got a federal unsubsidized loan. So that means the student is responsible for accrued interest with a 6.4% interest rate for 10 years. So notice the interest rate is different than in option A. And so because the student's responsible for the interest, now notice it doesn't say whether or not it's capitalized or uncapitalized. So if it doesn't say whether or not it's capitalized or uncapitalized, you can assume that the student is going to, that the interest is capitalized, that the student is going to pay that interest with their monthly payment when they're out of school. And so we're going to assume capitalized interest here. And so the first thing we're going to do is figure out the accrued interest. How much interest adds up while Parker is in school? And so it'll be important to note how long she was in school for. So it says 2 years and 3 months, and then a deferment period for 6 months. So that'll be important when we get to adding up all those months. And so first we're going to figure out the monthly interest rate. And we're going to do that by first taking the principal, which is $50,000, and we're going to multiply it by the rate. So this is 6.4%. So we're going to take the decimal and move it 2 spots to the left with a placeholder 0, so 0.064. So $50,000 times 0.064. And that gives us an amount of $3,200. That's per year, the amount of interest that adds up. Quite a lot. And then we're going to take that number and we're going to figure out, well, if it's $3,200 per year, how much is it per day? So we're going to divide that by 365.25. Since there's 365 days in a year plus a leap year, that's why we've got that 0.25 at the end. So divided by 365.25. And we're always going to round to the nearest cent, which is 2 numbers after the decimal. So $8.76 per day. Okay, and then we're going to take that number and we're going to multiply it by 30. We always multiply by 30 regardless of, it doesn't tell you, we just average out and assume that each month has 30 days just for the sake of calculation. And so, and notice here, I'm actually going to not leave that last number in the calculator. I'm going to retype 876 and multiply that by 30. And then I'm going to get $262.80 per month. Okay, that's important. So I'm going to take that number and I'm going to figure out, well, how many months is Parker in school? So number of months while Parker is in school, or deferment period would be that 2 years plus 3 months before graduation, and then another 6 months of deferment period. So I want to get that all into months. So 2 years, if I just multiply that by 12, I can get the months. So 24 months plus 3 months is 27 months, plus another 6 months is 33 months altogether. Okay, so Parker's in school for 33 months, and each month Parker is making a payment of $262.80. So now all we have to do is multiply. So we're going to do $262.80 times 33. And we get $8,672.40. And so that's the total accrued interest. And that's really important because now when we go to find our monthly payment, we need to find the principal because that's in the monthly payment formula. That's important. And so we know the loan amount was $50,000, but now we're going to have to add that accrued interest, so that 867240, we're going to have to add those together. And so we're going to take $50,000 plus 8672 and 40 cents, and we get a new principal of, well, and I say new compared to the last problem, which was subsidized, so $58,672.40. So that's the amount of money that we're going to use in the monthly payment formula. And then our rate is going to be 0.064. Our term is 10 years. And so I'm going to use the monthly payment formula and plug that all in. So I've got 58,672.40 times our rate divided by 12 divided by 1 minus 1 plus our rate over 12 to the negative 12 times 10 power. And for this one, I'm actually going to not use the N over D button. I'm just going to use the division sign, and that way this will apply for all calculators. So 58,672 and 40 cents times 0.064, and actually I don't even need that parenthesis. I get the same answer if I didn't put it there, divided by 12 equals, and this is the numerator, so I'm just going to write that out, so 312.9194667, and then I'm going to just do my denominator, so 1 minus parentheses 1 plus 0.064 divided by 12, and then raise to the negative 12 times 10, or you could just put negative 120 because that's what negative 12 times 10 is. And we end up getting 0.471810088, and we can divide those two numbers. So I'm going to just punch in that top number, 4667, and you can divide, you can type this bottom number in, or you can hit second and then that answer button, and it will automatically just take that answer from the previous step, and now we've got our monthly payment. So our monthly payment is $663, and if we round to the nearest cent, 23 cents. So this is per month, and so this is more than the last monthly payment. So our last monthly payment was $572.84. So you can see Parker is paying more per month, quite a bit more per month with this federal unsubsidized loan, even with a lower interest rate because of all of that accrued interest while Parker was in school. Okay, so now let's find the total cost. Okay, so to find the total cost, we're just going to multiply. We're going to take the monthly payment, the $663.23, and Parker's paying that 12 months a year for 10 years. Okay, so $663.23 times 12 times 10, and that gives us our total cost. And we're not needing to add any interest to this because remember, she's paying this interest after school is finished. So that 8,672.40 of accrued interest, that's factored into that monthly payment formula because she's capitalizing that interest. If the interest were uncapitalized and she was making payments while in school, then that'd be different. But anyway, so we're just going to multiply these together, and we end up getting a grand total of $79,587.60. And you might remember with the subsidized loan, the total cost was a little over $68,000. So more than $10,000 difference between those two loans. And this one even has a lower interest rate. Okay, so let's look at option C now, which is that private loan with 7% interest for 13 years. So with the private loan, we have a higher interest rate, which isn't surprising. Oftentimes private loans can have that higher interest rate. So interest rate of 7%, and then the student's going to take it out for 13 years, take 13 years to pay off this loan. And so we're going to go through the same steps as the last option B because, you know, in this case, this is still, even though it doesn't say, it's an unsubsidized loan. So private loans are always unsubsidized. The student is going to have to pay the interest that accrues while in school. So to find the accrued interest, we're going to first find the monthly interest by taking the principal, which is $50,000, and we're going to multiply it by the interest rate. So 7, moving the decimal 2 spots to the left, so we're dividing by 100, so times 0.07. So we're going to take $50,000 and we're going to multiply it by 0.07, and we end up getting $3,500. So that's the amount per year that accumulates while Parker is in school in interest. And then we're going to take that yearly amount, so the $3,500, and we're going to divide it by 365.25 to find the daily amount of interest. So divided by 365.25. And we end up getting a daily amount. Remember to always round this to the nearest cent, so 2 digits after the decimal, so 0.58, and this is per day. So almost $10 a day just in interest, so that's quite a bit. And then we take the $9.58 and we multiply it by 30 to get an approximation of what the interest rate would be per month. And then I'm going to type in 958 rather than leave the long decimal that was previously in my calculator. So times 30. And I get a monthly rate of $287.40 per month. So that's the amount per month that accumulates while Parker's in school. And so now if I want to find the total accrued interest, so total accrued interest, all I have to do is I have to multiply the $287.40 times the 33 months. And notice I didn't actually have to go through that process again, because that same 33 months that we figured out for the last option is, the same for option C, because, the student's in school for the same amount of time. So 287.40, oh, and I guess I could have just used my previous lines and just said times 33. There we go. And so we get a total accrued interest of $9,484.20. So that's almost $10,000 just in interest that adds up while the student is in school. Okay, so now we're going to take that number and that's going to factor into our principal. So when we find the monthly payment, we're going to take the principal or the loan amount, so the $50,000 the student borrows, and then we're going to add the $94.84.20 because that interest accumulates while she's in school. So I'm just going to put, oh, not times, we're going to go plus, and then $50,000. And we're going to add those together, and we get $59,484.20. And that's the principal. Our rate, we said, was 0.07, and our term, now you've got to be careful. I'm going to use a different color here. It's 13. It's so easy to get going with these problems and always use 10 for time. Occasionally, there's a different term thrown in at you, and you just got to pay attention there. Okay, so I'm going to go ahead and plug all that in. So my principal, $59,484.20 times my rate over 12, divided by 1 minus 1 plus my rate over 12 to the negative 12 times t power. So my t is 13 there. And so I'm just going to plug that all in. So the last time I did it separately, this time I'm going to use my N over D button. So 59,484.20 times, and again, if you don't have the N over D button, just do 0.07 divided by 12. And you'll get the same answer. And then we're going to arrow down the bottom, and we get 1 minus 1 plus, and then 0.07 divided by 12, raised to the negative 12, use the negative sign and not the subtraction sign, times the 13th power. Okay, and we end up getting 581. And so going 2 numbers out, or 2 decimal places out, we're at a 9, and the next number is a 9. So we're going to have to bump that 9 up, and instead of 79, make that 80. So it's going to be $581.80 per month. Okay. And notice this is actually a cheaper monthly payment than option B. So the monthly payment for option B was $663.23. Remember, this is a 13-year loan and not a 10-year loan. So it's easy to fall in the trap thinking, oh, this loan's better because it's, it has a lower monthly payment, but not necessarily. So we're going to find the total cost and we'll actually compare. That'll be a better way to compare. And then real quick, and feel free to fast forward this if you were okay with how I did it the last time, but I just want to write this out in case you want to see how to do this with a different calculator. You would just take that principal times 0.07 divided by 12 and get the numerator. So I'm just going to write down 346.9911667, and then I'm going to work out that denominator. 1 plus 0.07 divided by 12, and parenthesis, raised to the negative 12 times 13 power. And so we get a denominator of 0.596410138. And then I'm just going to divide those two together. And I'm going to use the answer key to make this a little bit faster. So divided by my previous answer, and I get the 581.80. So same thing I got before. So you've got two options there. Okay, so let's look at total cost. So I erased some of the blanks from the last option just because it's the same process each time. So we're taking our monthly payment. So in this case, I have a different monthly payment. So I'm going to put in that amount. So my monthly payment is $581.80. There are 12 months in a year, so that 12 is always going to need to be there. And then the last number is number of years, which in the previous two options I put 10. In this case, I'm going to put a 13 because it's a 13-year loan instead of a 10-year loan. So we're just going to do 581.80 times 12 times 13, and that gives us a grand total of $90,760.80. Okay, so now let's put it all together and kind of compare all three loans with this important information. So if we look at the three options, A subsidized loan that's 6.7% for 10 years, it has the lowest monthly payment, but not by much compared to C. So notice C's monthly payment, that private loan, is a little bit more than A. Don't be fooled there though, because you can see that the total that you end up paying for option A is a little over 68,000, whereas you're paying over 90,000 for option C. So remember, with that 13-year term, when you tack on years, it takes that monthly payment down, but the overall cost is actually a lot more. So what's the best option? Well, the best option clearly is A, and we can see, if you ever want to know exactly how good a loan is compared to the other, we can subtract. So we can look at the total cost of A compared to B just by subtracting those two amounts. So if I take the cost for B, which is $79,587.60, and I subtract the cost for A, $68,740.80, and I'm doing it in this order just so I get a positive number, we can figure out the difference between those two loans. So $587.60 minus $68,740.80, we get a difference of, did I put that in right? Let me just double check. It's different than what I had on my answer key. So $79,587.60 minus $68,740.80. Yeah, so that looks right. So my savings there is 10,000. Oh, I guess I didn't need $2 signs. $10,846.80, cheaper than B. So A is $10,846.80 cheaper than B. Okay, that subsidized loan. And then if I wanted to know, compare C with A, I could take the total for C, so $90,760.80 minus the A amount, so $68,740.80, and subtract those two. So I'm going to do that real quick. So $760.80 minus 60, oh, not 9, we're going to go back, $68,740.80. And we get a difference of $22,020. So that's really significant difference. So cheaper. So A is that much cheaper than C. And then remember, obviously, with subsidized loans, the government is paying the interest, so that's why you're getting that savings. A student has to apply to get that type of loan. So you could even subtract like options B and C to see which is better, because those might be the only options for a student if maybe they don't have a subsidized option to choose from. So the nice thing about this example is hopefully it will allow you to compare any types of loans regardless of what those parameters are. So, and as always, if you have any questions, feel free, definitely reach out to your instructor.